Good morning and happy Friday. Yeah, last day of January. Wow. Happy anniversary, Mr. and Mrs. Daniel. January 29th, 27 years Mr. Daniel's been married. Okay. Send Mrs. Daniel congratulations for putting up with all those dumb dad jokes for that long, right? Okay, you know the drill when we do these. You're going to copy this down and you're going to do your best and you're going to come back. Okay. Now on these, when it says decode, these are all units and equivalent measures. So 24H equals 1D. They figured that one out? That's going to be 24 hours equals 1 day. Okay. All right. Don't forget when you multiply the decimals, pretend the decimal's not there, then figure out where to put the decimal by counting how many places you had to move the decimal in the problem. So in this case, I had to move this over 2 spots to pretend that was an 18, but then another spot here to pretend that was a 4. So a total of 3 spots. So after I pretend there's no decimal, do 4 times 18. I'm going to have to go back 3 spots in my answer. Okay. All right. Good luck, everybody. We'll see you soon. All right, let's get these answers. 36 and 20. Now, I know 4 times 9 is 36, but 4 plus 9 is not even close to 20. I know that 6 times 6 is 36, but 6 plus 6 is only 12. So what's going to work here? Well, hopefully you figured out 18 times 2 works there, and 18 plus 2. How about 42 and 17? I know 6 times 7 is 42, but what's up with this 17? Well, you know how 6 times 7 is 42? If I take half of the 6 and I double the 7, my product will be the same. Okay? I can keep going in both directions. What's half of 3? 1.5. What's 8 or 14 doubled? 28. 1.5 times 28 will also equal 42. I can keep going that way. What's 6 doubled? 12. What's half of 7? 3.5. 3.5 times 12 will also equal 42. That works forever. Okay, so what am I talking about here is 14 times 3. Now, it's not just the 6 and 7. Over here, we knew that 9 times 4 equaled 36. And if I double the 9, I get 18. Take half the 4, I get 2. That's also 36. Okay? So it works forever in both directions on all products, where you could take half of one and double the other and get the same thing. All right, kind of cool thing to do in math. Anyway, here we go. 3 2/10 and 80 4/10. What is going to work there? That's just crazy, huh? Well, how about 80? Whoops. Oh, it's not going to work, is it? 80 400 is what I was supposed to do here. Uh-oh. Okay. It's Friday, Mr. Daniel. It's not even breakfast, and you already made a mistake. Let's fix that. Okay. Yeah, because when I go 80 plus 400s, I get 80 400s. When I multiply, I pretend there's no decimal, right? And I go 8 times 40, or 80 times 4 is 320. But then I had to move it over twice to pretend that was an actual 4. So I had to go back twice to get that. Sorry about that. Hopefully I didn't stump you too long. 6 3/4 and 5 1/4. Is that going to work, or did Miss Dana make another mistake? I think I did this one right. 3 2s is 6. 3/4 is 3/4, and 3 plus 2 1/4 is 5 1/4. Okay, I'm not going to write these out. You can. 60 minutes is an hour. 60 seconds is 1 minute. 360 seconds, right? 60 times 60 is 1 hour, 360 seconds. And if I do 360 times 24, I get 8,640 seconds in a day. Okay, you get 8,640 seconds every single day. Don't waste them. You don't get them back. All right. 1 pound, that's a funky L. When you write L's in math now, you should sort of not have it be straight down, because then it gets confused with a 1. Okay. And sometimes when you're writing letters and numbers, when I do a 1, I do a 1 with a fancy one like that. I have other numbers next to it like that. I don't, but it was just a 1 by itself. So 1 pound equals 16 ounces. Let's think about 1 pound and 16 ounces. Why, right, if the word pound is spelled Pound, do we abbreviate it with an LB? Anybody know? It's from Latin. If you guys follow horoscopes, you know that if you're a Libra, okay, the symbol for Libra is a scale, okay, and Latin, a Libra is a weight. So LB stands for Libra. The other weird thing about this, and again, this is all English, okay, we abbreviate 16 ounces with OZ. If you spelled out ounces, it is OUNCES, but you abbreviate it OZ. There's no Z's in that. Why? Crazy, huh? I don't know. I don't make the rules. That's why I teach math instead of language arts. This is crazy. All right. Now, the cool thing is about that LB, though, if you did not follow Mr. Daniels' advice and make your L kind of with a squiggly line and made a straight line, okay, what does those two letters kind of look like if you were thinking numbers? Kind of looks like a 16, doesn't it? Well, that's a cool way of remembering that there's 16 ounces in a pound, right? Because remember, general standard units of measurement, we have 16 ounces in a pound. We got 8 ounces in a cup, 16 fluid ounces in a pint, 32 ounces in a quart, 128 ounces in a gallon. That's going to mean that there's 4 quarts in a gallon and 8 pints in a gallon and 16 cups in a gallon, right? And we have 12 inches in a foot, 36 inches in a yard, 5,280 feet in a mile, 1,760 yards in a mile, right? All these different units are kind of crazy, right? So it's hard to remember them all. It's not like metric where you know there's 100 centimeters in a meter, right? 100 centigrams in a gram, 100 centiliters in a liter, right? That's kind of cool with metric. It's the same. No matter we're talking about length, capacity, how much something will hold, right? And weight or mass, how much something weighs, right? It's the same, right? Where standard is all over the place. So you need little tricks to help you remember things. That's a cool trick. There's 16 ounces in a pound. 1 pound equals 16 ounces, and LB kind of looks like it could be a 16. Okay. It's a little trick. Hey, if it helps you, it helps you, right? All right. 1,000 grams is 1 kilogram, and 1,000 kilograms is 1 metric ton. So a metric ton is 1,000 kilograms. Okay. All right. 8 ounces is a cup. I think we just went through these. 100 cents is $1. $1. 100 years is 1 century. All right. And then we have centimeters, centigrams, centiliters, all work out. Okay. When I multiply this, pretend there's no decimal. 4 times 18 is the same as half of 4. 2 times, 4 doubled, 8. Half of 18, 9. 8 times 9 is 72, and 4 times 18 is 72. But I had to move this over once to pretend it was a 4, and twice here to pretend it was 18. So I got to go back a total of 3 spots, and my answer 1, 2, 3, fill in the egg carton. So that's 0.072, 72 thousandths. Same idea here. Pretend there's no decimal. 7 times 2 is 14. Carry the 1. 7 times 3 is 63. Plus 1, 64. But I had to go over 3 spots here, 2 spots there. That's a total of 5 spots. I have to go back in my answer. 1, 2, 3, 4, 5. Fill in that egg carton. 0.00644. 7 times 8 is 56. Carry the 5. 56 and 5 more is 61. Carry the 6. 7 and 6 is 13. Put a placeholder. Cross those out so don't get confused. 4 times 8 is 32, carry the 3, and 32 plus 3 is 35, carry the 3, and 4 and 3 is 7. But these weren't really 47, 188. So I had to move it over 3 spots here and 1 spot there. So I have to go back 4 spots in my answer. So 0.8836 is my answer. Okay? All right. 5 times 0, 5 times 0, 5 times 0, 5 times 6. Placeholder, 9 times 0, 9 times 0, 9 times 0, 9 times 6. 0, 0, 0, 0, 7, 5. I have to go over 1, 2, 3 spots. 1, 2, 3. Okay, 570. Okay, all right. My goal is to isolate the variable. That means I want the x all by itself here. I want the y all by itself here. In order to do that, I have to kick everything else off the island. Now, when you have multiple operations happening, this is really x times 3, right? Or 3 times x, and a plus 7. You can't get rid of everything at once. What you want to do, this is y divided by 3, you want to go in opposite order of operations as you get rid of things. What does that mean? What comes last in order of operations? Adding and subtracting. So I want to get rid of adding and subtracting by doing the opposite first. Then I'll go to multiplying. Okay? So I want to get rid of a plus 7 first. How do you do that? Well, what's the opposite of plus 7? Minus 7. If I do it to that side, I will be out of balance unless I do the same exact thing to the other side, right? So let's subtract 7 from this side. Now they cancel each other out. All that's left on this side is x times 3. And this side I have 31.6 minus 7. Minus 7. Line up that decimal. The 7 goes here, not under the 6. Put a 0. So I have 24.6. Now, how do you get rid of a times 3? Well, what's the opposite of times 3? Divided by 3. And if I do it to that side, I'll be out of balance unless do the same exact thing to the other side. So times 3 divided by 3, they cancel each other out. All I have here is 24.6 divided by 3. I'm going to divide 3 into 24.6. Remember, there's a decimal inside the box. All you do is bring it straight up. 3 goes into 24 8 times, perfect fit. And 3 goes into 6 2 times. 8.2. Put a box around your answer. Are you done? You should go back and double check, right? Go check and see if 3 times 8.2 plus 7 equals 31.6. And 3 times 8 is 24, and 0.2 is 6. And 24 plus 7 is 31. Boom, it works. All right. How do I get rid of a minus 2.6? Add 2.6. If I'm going to add 2.6 to that side, my equation becomes out of balance unless do the same exact thing to the other side. Now, minus 2.6 plus 2.6, they cancel each other out. All that's left on this side now is y divided by 3. On this side, I have the total, the sum of 5 and 5/10, 2 and 6/10, and when I get that sum, I get 8 and 1/10. How do I get rid of divided by 3? I multiply by 3. That's the inverse operation or opposite. But if I only do it to this side, my equation's out of balance. So do the same thing to the other side. Okay? These cancel out. All I have is y. On this side, I have 3 times 8.1. 3/8 is 24. 3 1/10 is 3/10. 24 and 3/10. Now, if you want, go back and double check that. 24 and 3/10 divided by 3. equals 8 1/10, 8 1/10 minus 2 6/10. Got to borrow 5.5. Boom, did it right. All right, last three questions, 2 parts each. You need to find 2 names for each triangle, and George cannot be one of the names. Yeah, good dad joke, huh? All right, now this symbol right there signifies that is a right angle or a 90-degree angle. And if a triangle has a right angle, you can call it a right triangle. I'm just going to put the symbol there. Now, if all 3 angles are pointing, they're smaller than a right, you can call it an acute triangle. Acute means pointy, more pointy than right. Okay, if an acute angle, if it's really acute, then it's also called sharp, right? And acute is actually a synonym for the word sharp. And sharp can be used to signify an angle or a knife, but it can also be used to describe a person, right? If a person is smart, sometimes they're called sharp, and sometimes they say they're cute. That doesn't mean they have cute little dimples in their cheeks, right? Or puppy dog eyes. That means they're smart. So if someone says someone else is acute, they might not be talking about the way they look. They're probably talking about how smart they are. Sharp, okay? Dull is the opposite. So that could be acute. So that can be right. Now this angle here is way bigger than a right angle. An angle that's bigger than a right is obtuse. So this could be an obtuse triangle. Now you might notice this obtuse triangle, the other 2 angles are sharp. They're acute. You might notice this right triangle, the other 2 angles are acute. Okay, so all triangles have at least 2 acute. It has to be all 3 smaller than right to be an acute triangle, though. Okay, you can have 1 right angle, you can't have 2 in a triangle. All right, think about why. Got 1 right angle here. If I make another right angle here, these lines are parallel. That triangle will never close. Same thing with obtuse. 1 obtuse angle there. If I make another one, that's not going to be a triangle, is it? All right. So all it takes is 1 obtuse angle to be an obtuse triangle. All it takes is 1 right triangle to be a right angle to be a right triangle. It takes 3 acute. Now, what's the other name for this? George is out of the question. Here's your deal. All 3 of these sides are the same, so that can be an equilateral triangle as well. Remember what lateral means? Sides, equal sides. All 3 of these are different, so that can be called a scalene triangle. When all 3 are different, it's called scalene. And if 2 of these are the same, you guys remember that word? Isosceles. Isosceles triangle. All right, a little geometry, all vocab, huh? Draw these in your folder, right? In your composition book. Okay, have a good day, everybody.